Good evening, everyone. Hopefully we're well. Just checking you can all hear me okay. Is that tough for Joel? Someone just put in the chat for me if they can hear me okay. That'll be much appreciated. Wonderful. Thank you very much. Okay, people. This is it. This is your live stream for your Component 1 exam. Yes, I'm here working again overtime. I'm not working actually. This isn't for work. This is just because I'm obviously passionate about computer science. I knew Israel would be here. Hopefully the whole gang's here from my class. That'd be really useful. So next week we're doing the exam. We've got the Component 1 exam. It's worth 70%. 70% of our AS grade. Combine that with our Component 2 exam, which is the programming one. We combine all that together and work out our grade. So today, thank you very much for all those people that have put in queries about what they want me to cover. I've had, let's have a look, 14, 15, 16, 18, 19, 20 responses in there. Some people, the best name I had was Bob Free Bobbington. Thank you very much, Bob Free Bobbington, for putting in some stuff. Leon Maroof, Bahadine, Zirak as well. Who've I had? I've had loads. Sajan, Osama, Erion, etc. Loads of people have asked me to do things, so I've combined them all together. You got ads on your screen, Michael, because clearly I'm making money. I am monetized. So maybe halfway through the stream you'll get an ad. I don't know. I don't know how it works. I'm just going to roll with it. I've not seen any money yet. Don't worry, people. I'm not that famous. So, what we're going to cover. First thing, we're going to cover databases in the first thing. Then we're going to move on to organization of data. Then on to operating systems, networking, a little bit on truncation and rounding, and maybe some binary if people really want it. And then systems analysis to finish us off. We've got 2 hours, people, 2 hours. And I have made this unbelievable resource that I will send to you if that's what you want. All right, let's get straight into it. What I want you to do is I want you to ask questions in the chat if you have them. All I'm going to do, let me just get my chat up again. I've got loads of screens here. This is so confusing. Let's get started. So this is all the chapters, all the different parts that we can cover. So those with the yellow tabs, those are the ones that this document has resources in. So this one document, I'm not joking, it's about 500 slides or something, and it covers every topic. And I've built this over time as people have requested it on the live stream. So chapter 12, 13, so software engineering and program construction. 15, which is practical programming, which is basically actually your programming. There's no written stuff for that. It's all the stuff that you do. Then 16, data and security. And then 17, you've got probably the one that students love the most. I'm joking. Probably the one the students hate the most is legislation because it's bulky. There's loads of stuff in that. Now then, jump straight in. Let's get on to databases. Database always seems just to like trick people. Let's go down to database systems on chapter 7 then. So a couple of things that we're going to cover in databases. And the first thing is talking about relational databases. Can I turn the sound up? Can you turn the sound up? There we go. I'll put the sound all the way to the top for you. That's as loud as it's going to get, I believe. I've got one of these fancy Rode microphones and I don't know what on earth it's doing. It's slightly, it's part of the same document as last time. It's just combined all together. I've added some more stuff in because people have requested some more stuff. Yeah, I will. Hello. Let's get cracking, people. Let's get cracking. Relational databases, keys, indexes, and links. I'm not sure. Welcome, person that's not in my class. CIE for CS. What? What's CIE? I have no idea. This is all computer science stuff. It is useful. Trust me. Everything I teach is useful. Keys, indexes, links, entity relationship modeling. On your screen, there you will see a database. Okay, now the database here is a flat file database, and what does that mean? It means that every single row in there contains information, and all of it is in one table, right? So everything is in one single table, and that is not good. Why? Because we've got data redundancy. So a flat file database contains information held in a single table. So each column in the table is called an attribute, and each row is called a record. Now, what we need to do is we need to move from a flat file database to what we call a relational database. And we use flat file databases just for small amounts of data. If it gets larger, then it takes longer to search and it increases the chance of data redundancy. And that means that lots of data is being replicated, and we don't want that, people. We do not want that. So what we do is we go through a process called normalization. Normalization converts our flat file database into a relational one. So relational databases then. Relational databases are just single tables, all related. They're linked together through keys. That's it. Okay? Now, there's two types of keys that you're going to need, and that is a primary key and a foreign key. And once we can have those keys in place and we create our relational databases, hopefully the plan is we can remove repetition. Okay? The only issue that we've got is that, God, this is going to cause issues because it's well more complex. Much more complex. Right? Single table, easy to manage, loads of tables, loads of keys, loads of entities and relationships. That's going to cause more processing. So there's our keys. We've got a primary key, which is our unique identifier. We've got our foreign key. So the live is for 2 hours, top G, 2 hours. So that should be done at 9 o'clock roughly. So in your exam, if you're asked about a primary key, the first thing you need to write down is unique. You get a 1 mark for writing that down. Now, every single table must have a primary key. Every single one. Right? If it hasn't got a primary key, it ain't a table. Okay? A foreign key is a primary key from another table. So if you look here, for example, let me get my pen. Let's see what pen stuff we can do. You can see here that teacher ID is a primary key, and we denote that using a little star as well. There you go. Oh, it's doing that thing again. Oh my God. Imagine that was a star, right? Here, a foreign key is a primary key in another table. So that primary key is there, right? It's in another table. Now, this is where everyone gets lost. Most students can do primary keys and foreign keys. That's great, okay? But normalization is where people get lost. So all you got to do is follow the steps, people. So to get from a flat file database to a relational one, we go through normalization, and you're going to get up to third normal form. You can get given an unnormalized form table, and you're going to be expected to put that into first normal form. If you get a first normal form table, you're going to be expected to put it in second normal form. If you get a second normal form table, you're going to be expected to put it in third normal form, right? They won't ask you to jump any more than that. It's usually one normalization up, let's say. So in first normal form, you're going to remove repeating groups. That's all you're going to do, right? You're looking for what we call atomic values. Second normal form, you're going to remove interrelated fields. So break the tables down. That's what you're going to do. Third normal form, remove partial key dependencies and ensure that each attribute or each field depends on only one primary key. One key, one single key. That's what we're looking for. So let me show you what that looks like. Here is my unnormalized form. Okay? Unnormalized table. Now it's got repeating groups in there. I'm hoping that you've looked at that and gone, oh yeah, wait a second. There is some data, Jim Donaldson and Jane. Jim and Jim, there you go, right? So there's only one Lucy and one Jane. There's two Jims. That means you've got two student IDs, even though the two student IDs are the same, gender, date of birth. The only thing that's changed is one does maths and one does computer science. All right? So a table is said to be in first normal form if each field contains only one piece of data. Now, currently, every single element of this here contains one piece of data. So that's true. And all the attributes in the table are dependent on a primary key. Now, is there a primary key in this table? Well, currently there isn't a unique primary key because these two are the same. And that's not good. After we've looked for that, this is not maths. Get in the bin with your maths. The second requirement for first normal form is that all the attributes in the table depend on a primary key, and that has not been solved yet. So we need to fix that now. So now we take our table, take the table, and we split it up, right? Now, yes, okay, we haven't finished. That should say Donaldson. Let me just change that. So student IDs, we've got two student IDs again, Jim Donaldson, but look what we've done this time. We've broken off the student IDs and the courses and split them. So now, student ID. So if the student ID is a primary key over here, then that must mean that it's a foreign key in here. Course ID is now a primary key. But again, you've got two values and two values, so we're going to need to fix this. So the table is said to be in second normal form if it's in first normal form and it contains no partial dependencies, so nothing relying on something else. Now, for example, if I took student ID and course ID and I combined those together, would I get a unique identifier? And the answer is yes, I would. 67222 and GY51. There's no other combination like that. So these would all be unique in the two columns or the two attributes here. Now, if I said to you, okay, Jim Donaldson there in this table, who is this student? And you'd say to me 67678. Go up to this top table here. This is 67678. That is Jim Donaldson. Then if I said, okay, use this person then, 67677, you'd say, well, that's Jane. And I said to you, okay then, if that's Jane, what does Jane study? And you'd say, okay, FU451 is physics, and then there's teacher ID 4445, and that's Mr. Sorrell who teaches maths. Right? So this is what you got to think about now. You got to think about, is this table actually correctly broken down? And these database questions require you to apply a bit of common sense, because I'm looking at this now going, okay, well, the student and the courses are together, but the course names are dependent on the course ID, and that could be split down further. So I could make a third table. So breaking that down further, we've got our student table down here. So this is our student table. We've got our course table. So I'll put course there. Course. Student. And now I've broken it down and I've got a teacher table. I've got 3 entries, maths, physics and computer science. I've got still 1, 2, 3, 4 entries in there. Now the only thing that, again, I've still got Jim Donaldson in here, Jim Donaldson in here. Now combining those two together, to make what we call a composite key, they are still unique, but I'm still not happy with that. Okay, now, if I said to you, Jane Jones in here, student 677, studying FU 451, we can tell that that is physics, and that physics is taught by Mr. Surrell in the teacher table. Okay, so a table is said to be in third normal form if it's in second normal form first and it contains no transitive dependencies. So what that means is a transitive dependency is one where the column depends on another column that depends on the primary key. So for example, the student name here, actually let's pick the course, student name and student ID. If I told you 67678 was Jim Donaldson, you could say that's the same for that one. I've got FU451, that's fine. Mr. Surrell, they're all separate. So there are no transitive dependencies in here because, remember, a transitive dependency is when one column, so a single column, depends on another column, and that other column in the same table depends on the primary key. Okay? Now, the fastest way for you to work that out and to put something in third normal form is to see if you can split the tables down as much as physically possible. Okay? So let's see if I can break this down further. Now then, what's just happened there? I've got now a student table still. And my student table, I've lost my pointer. So my student table still has all my students in. What's disappeared? The course ID has been removed from the student table. Now, if I said to you, Jim Donaldson, 67678, what about them? Okay, now you could only tell me what that person's doing from this table here. This is the primary table. So that's where we start off. That is the main table that we sit in. If I asked you which one of those is the primary key, what would you say to me? Which one is the primary key in this table? Is it student ID? Is it course ID? Or is it both? Some people saying course ID, some people student ID. Okay. Now just remember that with this example, this person here, and this person here, that is redundant data. Duplicates. Over here in the course ID, duplicate and a duplicate. Now together, when you add these together, concatenate them, whatever you want to do, they become unique. So Tuffagel's right, it is both. And then I can work out what table, what course the person's doing. GY51 will take me to maths, and then maths takes me to 4445. And that's right, it is a composite key. Now we only use composite keys if we can't find a unique key. And that's why we've done that. Now that example is a tricky example. I'll go back to our original to see what we've done. Okay, that is our flat file database, and it contains all the information. When I look at that database, I can see that the student names, the student information is all here. So I'd slice at that point there. The course ID, course name and course ID, that is there. And then I've got teacher ID, teacher name, and teacher specialism. I'll give you a little tip for the exam. Anytime the header says ID, that's usually a primary key. And that's where your next table would start. And it makes sense, doesn't it? Student ID would contain all the students. Course ID would contain all the course information. Teacher ID would contain all the teacher information. So that's the splits that I would make. And the only way that I can connect them together is by including the course ID in this table as a foreign key, with my student key being the primary key. And if the course ID is a foreign key, it needs to be a primary key in its own table. Teacher ID could connect to the course, but that would make teacher ID a foreign key. And the teacher ID is a primary key in its own table, therefore it also needs to be a primary key. So after that, we split the first table off. That was the courses and the teachers. And then after that, we fixed our foreign keys to make sure there was no transitive dependencies where one column depends on another column that depends on the primary key. And that's why I ended up with the student and course ID table. Now, one thing, if you are confused with that example, there is an even better example. I produced videos on this because students were getting confused. I produced a series of database videos. So go and have a look at my normalization videos online if you're still struggling. Now, some people would have recognized between the tables, there are relationships. So here is a relationship, there is a relationship, and here is a relationship. And those are called entity relationships. So an ERM is a entity relationship model. And that's a diagram that we give to somebody to build the databases in the relationships that we want. So we have a number of different connections here. We've got one-to-one, one-to-one. So for example, a single country has a capital city. So below you can see here that this is what a database table would look like. We'd have the primary key, country ID, and the country ID would be France, and then in the second table the capital city would be a primary key, Paris would be the answer, and country ID is a primary key in the other table, making it a foreign key. Then we've got one-to-many relationship, where one teacher can teach many classes. We've got our many-to-many relationship. So many students sit many exams, and many exams are sat by many students. Now the issue with this is it does cause redundancy, so we have to go an extra step in this case here. All right. If you see this in an exam, then you need to do these following steps. The first one is to remove the relationship altogether. Okay, so we remove the relationship of the many-to-many. We insert a third table. This is our third table here. And that is a contraction. It's a joint of the two names. So we've got student and exam to produce student exam. And I like to call this a linking table. And this is what we saw before with student IDs and course IDs. That was a linking table. Once we've got the name, we then flip the relationships So these relationships are many to many. We change for a one to many and a many to one. Okay, and that reduces or puts it in third normal form for us. So if you ever have a many to many relationship, you need to change it. And that's what it looks like in database form. You have student ID, which is a primary key. You have student ID in here, which is a foreign key. Exam ID in here, which is a primary key. Exam ID in here, which is a foreign key. And together, they would make a primary key. Hello. Hello, person in the chat. All right. Now, what about this kind of question here? Do you make a unique ID for student exam to link in the tables? You just you just bring the two foreign keys together. Okay. So, this is a typical question that we get in an exam. In a certain college, students are able to attend evening courses which are taught by tutors. Now notice the italics here, people, because they give you little clues like this which help you out. In a certain college, students are able to attend evening courses which are taught by tutors. A student can attend any number of courses and each course is taught by a single tutor. Although a tutor may teach more than one course. If you have some paper, if you have a whiteboard, by all means you can try this out. It is required to design a database for this situation. A. Using an example, explain what is meant by a primary key in a database. Another live. Tomorrow. What do you think? What do you think? What is this? What is this? I am actually busy tomorrow, so the answer is no, unfortunately. Right, use an example. So a primary key field which uniquely identifies a record in a database. That is what a primary key is. So the word unique, record goes in. So if I talk about unique records, that'll get me 1 mark. All right. So in this database, can anyone give me a primary key for this example? Students. So usually, yeah, so give me something, yeah, normally it's an ID of some kind, right? So I could have students there, which would give me a student ID or a student number. So students ID would be 1 mark, courses, course ID would be 1 mark, tutors ID would be 1 mark, all right? What is meant by third normal form in a database, right? So remember, third normal form means that data items, things in your database, are dependent on the whole key, right? No partial dependencies. They say this in like law. The whole key, nothing except the key, or nothing but the key, right? Just one single connection to a key. No partial dependence. I'm not going through another foreign key to get to the primary key. No. So this might help you remember it. Key, the whole key, the key, the whole key, and nothing but the key. Construct an entity relationship diagram to illustrate this situation. Okay? So, firstly, what have I got? Let's do it over here. Apologies for my drawing because this is going to be tough. I can just see it coming. This graphics tablet, it needs an upgrade. Student table, right? I've got courses, or courses. Yep. Straight to third normal form. Because it's not been given to you in this isn't first normal form. This is just a description. So I've done students, I've done courses, and I need tutors. Right, so I'll put tutor down here or something like that. Doesn't matter what order you've got them in. You won't lose marks for the right order. Right, now, in a certain college, students are able to attend evening courses. So students attend courses, right? And they are taught by, which are taught by tutors. So courses are taught by tutors. A student can attend any number of courses. So students attend any number of courses, and each course is taught by a single tutor. Okay, single tutor. So tutor teaches courses, although a tutor may teach more than one course. So, right. Now, courses, a student attends a course, but courses, that must have more than one student. I mean, how many courses do you know that have one student? Let me just read that again, make sure I'm correct. In a certain college, students are able to attend evening courses which are taught by tutors. A student can attend any number of courses, yes, and each course is taught by a single tutor, although a tutor can teach more than one course. Yes, I think that's right. Now then, what's happened here, people? What's happened here? What relationship have I got? Oh no, many to many, right? So, if I got this in the exam, what I would do is I would draw this again, course, right? This is a separate diagram now that I'm drawing. Course. Student. Tutor. That one is absolutely fine. No problem. It's this one that's the problem. This one's the problem. So again, you create a new table. You have a contraction. So that's a joint. I'll call it student course or course student. Doesn't matter which way around it is. Student course. Okay. And you flip the relationship. So one to many, many to one. Right? And they are all your marks for that question. It was worth 3 marks. 3 marks. Okay. Now it says design the database for the above situation in third normal form. I will be doing an A2 stream. I have not decided when. Not yet. But I plan on doing one, yes. So if I'm going to draw this now for this question, I need to draw my tables first. So you get 1 mark just for writing the tables. So I get student. There you go, student. Tutor. Course. That's the 3 that I had before, and my many to many one, I've got my linking table now. So I called it. Oh, come on. No, come on. Oh, so fiddly. That's a student course, by the way. Okay. Now, open the brackets, open the brackets, open the brackets, open the brackets. So these tables have fields inside them. I need a primary key for student. Let's go student ID. Right? Now to make it a primary key, we draw a line underneath it. Tutor number. Tutor ID or something like that, right? Line underneath it. Course. Oh, look at this. Course ID. Line underneath it. Okay. Now, that's the three done there. Course ID, tutor ID, student. Right, so student, what does it have inside? What might a student have? Oh, it might have name. Name of the student. Might have their address. Whatever. Right? You can close that off there. Who knows what else it has, right? How would you put the line above the word to show it's funny? You just draw the line above. Thank you, Emirates. You're quite right. Tutor. Well, what do tutors have? Well, tutors like me, I have a name, apparently. Name. This is so annoying me. Oh my goodness. 1 minute. Why does it keep doing that? Name. What else we got? I teach in a room. I might have room. Whatever. Okay. Now, that's fine for course and student, but we've got this weird relationship going on now. So the course has many tutors. So we need the tutor ID inside the course. Because we need to know what course is taught by which tutor. So tutor ID, right? Okay, there you go. There you go. So that means it's a foreign key and a primary key. So it's a primary key in another table, it's a foreign key in this table. Right? Tutor ID, tutor number. So now we know which tutor is teaching which courses. And the linking table, right? The linking table brings together the course ID, the student ID, all together. Course ID, comma, student ID. And both of those are primary keys, and they're also foreign keys to make a composite key. Okay? That is it, people. That is it. That will get us our 6 marks. That if we get our entity relationship model right, we're going to be well on our way. You get 1 mark there for just stating your tables. You get marks there for your primary keys. You get marks there for the rest of the data that you would have. Now, if it doesn't say it in the question, you can just make it up, but be realistic. What would the student come with? What would a tutor come with? What would a course have inside of its database, for example? Okay. There are loads of questions out there on databases. If people want more questions for databases, you just need to let me know. Now, sometimes those questions can appear on the component 2 paper. They flip between what they want to do in this exam board. Okay? Any questions about that? Before I disappear back to the main screen and we look at organisation of data. Yeah, Maruf, let me write that down while I'm here. Anything else? Awesome. Right. Okay. Okay, people, let's go to the next bit. Do we need to create a table? Yes. What next? Organisation of data. Oh my goodness gracious me. Where is that? we go. Are you ready, people? Files and file design, serial sequential file access, file security, archiving, data validation, verification. You know what? To save a bit of time, state in the chat what validation methods we use. What validation methods we use. Presence check, yes. Length check, yes. Any more? So presence check to check it's there. Length check to check how many characters we got. Type is a data type check. We've got check digits, which are usually used for barcodes. Range check to see if it's between a certain range of numbers or characters. Yep, checksum. Yeah, again, barcodes. We also have checksums and parity bits in data packets as well when we're networking. Any others? You got most of them there. Right, here is another question for you then. I'm making you work hard today, people. Making you work hard. There you can see a table. This is a format question. It was the first question on one of our exam papers. And it states, yep, Tougher Joel. 8 bits for what? You can't just go in there, Tougher Joel. ASCII. Okay. Boolean. How many bits for a Boolean? 1-bit, 8-bit, 24-bit, 16-bit. Oh my days. You're right for some of them. Right, 1 bit for Boolean. ASCII. ASCII, American Standard for Character Information Interchange. How many bits? How many bits? Remember, the question says bits, not bytes, bits. No, ASCII string is 8 per character. Yes, it is 8 per character. You can also have 7. So 7 is standard ASCII and 8 is extended ASCII to fit all your silly emojis in for your emotions when you're messaging people. ASCII string is obviously then 7 or 8, depending on what you choose, per character. What about a short integer? Always trips people up, this one. Always trips people up. You could calculate this if you wanted to. You go up to 1, 2, 4, 8, 16, 32. Remember the question asked for bits. Well done, Tough Joel. 16 bits. 16 bits in total. Okay. Right, you ready? Buckle in, people. Buckle in. What is a file? Well, that is a file, but in computer science terms, what is a file? So a file is a collection of related records. Right? So inside a file, on your computer, it has records inside it. Inside each record, it has a number of fields. Okay? Now, a record is a data structure. So if I draw this for you, get my pen, right? If I was to draw this, it would look like file. Inside that, you would have a single record. And inside there, you'd have data, 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 data. Then you'd have a second record. And that would have data, data, data. Okay? So, there you go. There's an example of a record for you. Now, we have things called fixed length records. And fixed length records, they save the data or store the data in the file and they store it in a rigid way. So we have to work out the number of bytes that each field has and add them all up. Now, we know that arrays, which is a data structure, arrays have just one data type. You're used to Python and you cross-reference arrays as lists all the time, but they are not the same thing. A list is a Python data structure that works exactly the same as an array, but it holds different data types, which is one of the benefits of using a list. A record can have multiple data types under one identifier. So that sounds more like a list. So what you're looking at there on the right-hand side is a record because it has multiple data types. It has strings, dates, integers, floats or reals and booleans. Okay. Now then, inside the record, we can add them all up, and the size must be stated up front. You define the size of your records, and we need to know that because we build a file, we have to structure it to set length requirements. If we're using fixed length records, that is. So how do you work out the file size? Well, you just add all them up on the side. 20 plus 30 plus 6 plus 1 plus 4 plus 1, and that gives you the total size of one record. How do you find out how many records you have in a file? You take the size of the file and divide it by the length of one record, and that should tell you how many records are stored in your file. So now we move on. That's just a prelim. We move on to some different file types. The first type, the easiest one, should I say, is serial files. Yes, do you get the joke? Serial. So serial files are the most straightforward method of storing files because new records are just appended to the back of the file. So if you do Python, you'd open it in append mode, you'd slam your record in, and you'd move on with your life. Therefore, they're all stored in chronological order. Rohan, be quiet. Important because we always have to open the record in append mode. If we open it in write mode, it can go anywhere, providing we give it a location, that is. Okay. Now, opening it in append mode, it forces every single file to write at the end of the file. And when I say chronological order, that is an order of time. It doesn't mean the data is ordered. The data isn't ordered, but the time it went in is ordered. So in serial files, they tend to be used for situations that don't require any data order. The number of records are usually small, and the data must be stored in the order that it arrived. And we usually see in the exam, we usually see examples like swimming races, road races, anything that basically requires time to be recorded rather than the data. So watch out for that in the exam. The next one we're going to talk about is sequence. Sequence is some kind of order to it, and we have two types. We have sequential and indexed sequential files. And an indexed sequential file works in the same way as a book. So you see your indexes there. Why do we use an index? Because it's faster. We jump to the group heading first, and then we go through each individual record inside that. So sequential files will order records based on a primary key field. We've just done primary keys. It's a unique identifier. Then, one field in the fixed length record will be used to order the records in either ascending or descending order. Why might we use sequential or index sequential files if they're in order? Does anyone know what search algorithms that we would use if the records were in order? What search algorithm would we use? What uses an order? Very good, people. A binary search. If you're saying a linear search, that doesn't require an order. Linear searches, it doesn't matter. We have to check everyone regardless. Okay? So it's a binary search. And that's one of the advantages over serial files. Okay? So just remember, binary, how does it work? You have to order it first. It finds the mid element or the middle element, and it searches the upper part of the list or the bottom half of the list if it's not found at the mid position. Okay. So with sequential files, inserting into them is more complex, okay, than simply just appending. So this is how it works. I will draw this for you. Shouldn't take long. So here is my file. That was good, wasn't it? My file has a record. That's record 1, record 2, record 3. Okay. Let's do record 4. Right. I want to insert a new record in this position here. What we need to do is we need to create a new file, copy across number 1, copy across number 2. I'll call this new file.txt. And I've copied the 2 across that I need to copy across. Then this is the point of insertion. So then I insert my new, let's call it 2.5 in there. And then I carry on and copy the rest across. There's 3 and there is 4. It needs to remain in the same order. After I've done that, then I will delete this file. I will get rid of my name, new file, and rename it what the old file was called. The computer then looks at it like it's exactly the same because it's called old file. And that is how we insert into a sequential file. Now deletion's the same. So deletion, what you would do is you go through each one, find the point of deletion, and then you just wouldn't copy the element and you'd skip it and carry on. And that's how deletion works. Deletion is not actually deletion, it's just not copying. And you'll do more on that next year as well, which is good for you. And there's the notes for you to pause it if you need them. And that's all the process I've just explained. Feel free to pause that if you're watching it after the live stream. So index sequential now, you are going to group the data by an index. And that's much faster because we jump to the group heading first and then we'd search through the actual subgroup itself. So the index will group the data into logical chunks and store the file location where that record began. We jump to the start of the record and then we just search through past the index until the next index. And if it's there, it's there. If it's not, it's not. It's just like a book, remember? So our index of our book, we'd find the A letter and then we'd search through all the A words in there. Now there are a few disadvantages associated with index sequential files, and that means things like it makes insertion and deletion much more challenging because we've got to do a lot more processing. It will cause issues because we are dealing with extra memory now. When you say writing the wrong things, Maruf, there, you need to explain yourself a bit further. What do you mean the wrong things? Just remember in index sequential file that every time we need to add something, all the heading positions, if we're using index sequential, the headers have to shift. So we might be adding a new record into header I, for example. So everything has to shift down a little bit, which causes a knock-on effect to everything else. And everything has to be updated all the time. And that does take a little bit of processing there. It's much easier if we just stuck it on the end. Maruf, you wouldn't lose marks. We do positive marking, so we are giving you marks, awarding credit for good answers. So you wouldn't lose marks for writing random things. Don't know why you'd want to anyway. Now, if I was to say to you, in an index sequential file, or a sequential file, if I was to say with you, I parked my car in the Spindles car park. It's a multi-storey car park if you don't live in Oldham, right? Multi-storey car park. If I said I've parked it in there, how the hell are you going to know where it is? How could I explain to you where I've parked my vehicle? Well, what I'd do is I would say, right, well, it's on floor 2. It's in zone F. in car park space 23. There you go. You've now got access to my vehicle much faster, right? If just by telling you the floor, I have reduced the number of possible search options, and that is called multi-level indexing, people. Multi-level indexing. So having an index can speed up searching by limiting the number of searches to a group of records. Okay, but what if the index is so large that it takes time to search the index and then find the group of records? If we've got millions and millions of items, yep, we would use another level. Okay, so there's an example. And this is just like the example I've just said. So here, this is floor 1, this is floor 2, this is floor 3, this is floor 4, this is zone 1, zone 2, zone 3, zone 4, right? You could say, oh, it's on floor 2, zone 3, and that would take me directly to that without having to search all of these and all of these and all of these. Therefore, it saves time. Okay, that's the main point there. Then we've got random access. So we've done so far serial, sequential, index sequential, and now we're looking at random or direct access. Okay. So what random access does is it involves jumping to a record without needing to search through numerous records. So this is often the preferred file handling method, all right? But it uses a hashing algorithm to determine the location. So if you need to be able to find a record's start position without having to probe the file in any way, you'd use direct access or random access. So the only information that we have access to is the data itself. So let me explain what I mean by that. Right? This is the worst hashing algorithm in the world, but you get the point. Right? So data. What data can I put into the system? John. Right? Here is my algorithm. Okay? My algorithm just determines the length of the string. Then it spits out the index position. So that would be 3 for John, wouldn't it? Jon, 3. So in your file, in record number 3, 1, 2, 3, this is where you would store John. Yeah, simple as that. Simple as that. Now what's good about that is if I need to search for it, retrieve it, all I need is the data that was used to store it. So I need just to ask someone, well, what was the name you're looking for? I'm looking for John. Okay, thank you. Put it into the hashing algorithm again, the fluffy cloud in the middle, and then it spits out. And that's it. Now I've added random direct access on there because it forms a part of the file handling syllabus, but it's more likely to come up on your A2 paper. All right? So as long as you stick to serial, index sequential, and sequential, you should be fine for the paper on Tuesday. So it stores it based on the letters / bits in the name, yes. And you can have as complex hashing algorithm as you like. It's up to you as the programmer to develop the hashing algorithm that's robust. So I might have said, okay, take someone's name length, multiply it by the number of characters in their surname, divide it by the year of their date of birth, mod that with 3, and that's going to be my index. So you can make it as complex or as simple as you like. Okay. So direct access files are split up into blocks, and each block contains a fixed number of records. Our hashing algorithm determines what block we're going to put the data in. And the file does have a maximum capacity and is created on the storage device in full. If you make it to next year, I'll tell you a fun little story about a student that basically shut down all the file storage in the college using a hashing algorithm. Very interesting. I'll tell you that next year if you make it. Okay? Now, master and transaction files. Master and transaction files. So what I want you to do is think about, with these two, so here we go. We've got master files which contain everything ever about you. So let me explain. John's got a mobile contract, okay? John's mobile contract, he pays a certain amount every month. He makes calls, text messages, uses data, etc. All that is stored in a transaction file. I get billed every month. So they take the transaction file, work out how much I owe, and then I produce a bill from that. I then pay the bill, and then the transaction file data goes into the master file, and then we reset the transaction file ready for the next month. Okay? Why do we use a transaction file? Because it's faster to search, because we're not holding all the data all of the time. Also, inside your master file, we contain all the data ever, which means we have an archive of information if we need it, only if we need it. So things like freedom of information requests or police requests, etc., where I would have to go and get that data, right? Not saying the police are searching through my phone data. That's not what I'm saying. Okay. Direct debits also work, yes. Transaction files will store data collected over a short amount of time, for example, the current month, week, day, even. So although the amounts of data we'll produce is still large, it's nowhere near the same scale as storing data for all months. Transaction files act as temporary files to help keep the system running quickly, but storing all the required data. And at the end of the short time scale, which is dependent on the scenario, the data from the transaction file is copied into the master file. Master files store all the data required, and they perform something called batch processing. We'll talk about batch processing a little bit later on. But they are also used to perform data mining. So data mining is basically extracting data and learning from it. Master files are not used on day-to-day because they're too large to use. Simple as that. And due to them being very large, we don't search them unless absolutely necessary. So, in your exam, you could be asked to draw a diagram. So, what does a diagram look like for a batch process? Well, it uses these things here. And this is a magnetic tape, which is an old school form of storage. That looks more like a shoe. Let me draw it a bit better. There you go. And you're going to have 4 data storage items in your diagram. You're going to have a process box in the middle. You're going to have an output of some kind, which will be your bill. Line out, line out, line it in. So, what is your process? Let's take our phone bills. So John's transaction data goes in. So this is my transaction file. All that data for the month goes in. The master file data goes in as well. That all goes in. The process gets produced. And then here we get an updated master file. And this one, can anyone tell me what this one is down here? Anyone tell me what that is? It is an error file. Very good. Okay. So it's an error file. Now the error file is useful because as we produce millions and millions of bills, a batch process is ran overnight when there's not much requirement resource on the system. It's a completely computer automated system apart from a human who starts it. So in the error file, if we come across any problems, then we just won't calculate and produce the bill. We'll just put it in an error file so someone can come and do a human check the day after and carry on. Okay? So there we go. Now, does anyone know the difference between a backup and an archive? What is the difference between a backup and an archive? Excellent. So a backup is a copy, okay? It's the process of copying files, whereas archiving is the process of moving files. So copying and moving are the two key words that need to be included in this. Now, things we need to think about. Backup is the process of copying files from the main area that's used to a separate area. So that means if we deleted files or something happened, then we could recover that later on. When creating a backup policy, you need to decide on where the backup's going to be stored. It should be off-site because of, natural disasters. What it'll be stored on, what the fastest possible storage medium, how often the backup will be taken, so usually not during peak hours, and twice a week, 3 times a week, every 15 minutes, you've got to decide, and how long you keep it for. Okay, so there we go, off-peak hours. The more often the backup we do, the more secure it gets. However, there is a trade-off between how often you do the backup and how long you can keep the backup and how much storage is required, because storage is not infinite, people, no matter what you believe. Now, eventually, no matter how much storage is used, old backups will need to be deleted in order to make way for new backups. And if you keep backing up all the time, then it takes ages and it takes up a lot of memory. So we use something called incremental backups, and that's the modern approach. So basically, a whole backup has to happen first, and then after the whole backup is done, we only back up subsequent changes in there. And that reduces the overhead of the backup, and it means it can be done more often. So we're only updating changes, and that's what banks use nowadays. And you told me that archiving is the process of moving a file. So there we go. If the files are not in a day-to-day use, then they could be archived. Archiving is the process of moving a file or a record from the main system to a separate archive system. Archiving old files will speed up the overall run of the main system, but still give access to the files should the need arise. Once the files are archived, they still need to be stored somewhere though. So you've got to think about the storage requirements. Sometimes people put them on hard drives and then put them in a safe. The college used to put them on magnetic tapes and put them in a secure storage location until 6 years had passed and we'd destroy them. We would destroy them. Now we get onto the operating system, people. The operating system. So we're about an hour and 9 minutes in. Everyone feeling good still? Oh, this is... Oh, I'm getting too old for this, people. This streaming malarkey. Right, let's go for the operating system. So what is it? Does anyone know what an operating system does? We don't keep them on magnetic tapes anymore, no. The green on the chapters means that the resources for that are not in the presentation that I'm using. That's all. I always add in just the stuff people ask for. Thanks, Gordon. What is an operating system? All right. Stay focused, people. We do have an exam on Tuesday. Right, manages backing store peripheral devices, drivers, processors, and spooling. Yes, it does. Now, an operating system is the most important piece of software that you actually run on your computer. So it manages everything that the computer does. Memory, processes, all of it. Hardware as well, connects to it, it runs it. All through your motherboard, everything is connected using our buses, but it also allows you to communicate with the computer without knowing how to speak the computer's language. It converts everything from a high-level language to a low-level language. High level being the language we're speaking in now, to a low level, which is basically machine code. So there's Bill. Bill, in 1985, launched Windows. Yes, and it's fascinating to imagine the amazing things people will do with their computers in 30 years, and then that's what people do. They produce memes of cats. This is your generation. I hope you're happy. I hope you're content with what you've done. Anyway, then this guy came along. It's been around all the time, actually. This is Linus. He released Linux 1.0 in 1994. I was 2 years old then, after releasing 0.02 in 1991. And now it's got a nice GUI, graphic user interface, on the front. All right. Then after that, this guy, Tim Cook, who's now the CEO of Apple. Before that, it was Steve Jobs. So Tim Cook released iOS in 2011, the sleek design of the iOS, and they ventured into their own operating system stuff. And it was all preceded, or came in after, let's say, Steve Jobs. Steve Jobs is the GOAT for Apple. All right. System software. System software runs behind the scenes, and it's a type of computer program that is designed to run a computer's hardware and application programs. System software is literally essential in order to perform most basic tasks. There are things going on in your computer that you don't even have a clue that it's doing. If you go to your task manager now and have a look at all the different processes, I guarantee you know nothing. You know nothing. The two most common types of system software are the operating system and also system startup software. That's the black screen that runs all your peripheral devices to make sure that you've got everything connected so that it can start the computer. Okay. Right. Now then, application software is less important, let's say, right? But basically, they are programs and they help with performance of the computer. They help with the needs of the end user. Their job is to support what you do. You might even buy them, like off-the-shelf software, like word processing, spreadsheet packages. You might even get yourself an antivirus, for example, even though an antivirus is a type of utility software. And that diagram there shows you what you're going to get asked about when it comes to operating systems. So operating systems have utility software, which covers antivirus, compression, debuggers, screensavers, system monitors. They also provide an interface, like a graphic user interface there. So a GUI, let me just write that in. A GUI, or a command line interface. It can also, the operating system can manage resources, which we'll talk about in a minute, and they're the 4 processes that it manages. It does also manage more than that, like spooling, for example. All right, mode of operation. There are 3 types of mode of operation. We talked about batch processes already because this uses master files and transaction files. Okay. Disk defragmentation, yes, correct. That is a utility software or a piece of utility software. It's getting less and less talked about now because people are moving away from hard disk drives. They're moving to solid state instead. So utility software helps people configure, analyze, optimize, and maintain a computer. So the software normally consists of small programs which are thought of as a part of the operating system. Right? They get access through the control panel. You use them. You can keep them running in the background. You can use them on startup. Make sure you cover all the topics in the theory. Excuse me, wealth therapist. No, it's physically impossible to cover a whole year's worth of work in a 2-hour live stream. Are you insane? Anyway, so system software is supported by utility software like the file manager, antivirus, and disk defragmentation, for example. There you go, all there. You can talk about any of those actually if you want to. Software updates. Some of them run in the background, some of them run all the time, some of them even slow your computer down. I'm not going to lie, I don't have an antivirus. Because I am the antivirus. That's why. Right. One thing the specification asks for is to talk about the kernel. Yes, not Sanders, not the KFC fella, yeah, not your favourite chicken man, right? The kernel. The kernel is a part of the operating system that mediates the access to the system resources. So the kernel sits in between the applications and the CPU, memory, and devices. So it's the middleman. And it's literally one of the most important things you've got. And the Linux kernel is probably the most famous kernel of all because it's open source. So the kernel is responsible for enabling multiple applications to effectively share hardware by controlling access to the CPU, memory, disk I/O, and networking. The smarter the kernel is, the more efficient your system will be because it transfers ownership and responsibility across lots of different devices like the CPU, memory, etc. All right. An operating system is the kernel plus the utility software that enables the user to get something done. That might be a compiler, a text editor, a Windows file manager, defragmentation software, the start menu, graphic user interface. That is all combined to produce the operating system. All right. What question would you get asked about the kernel? So you could get asked to say things about, explain the importance of the kernel in an operating system. 4 marks, for example. How does he do it? How does he do it? I don't know. Okay. This is what you came for. The overview of the operating system. So you've got the applications. That's all the software. It's the word processors, the spreadsheet packages. You can save files, print, display documents on the screen, PDF, Adobe, all that good stuff, right? Operating system. Even the simple process of opening a new window is handled by the operating system. You've got hardware drivers. A driver is a piece of code that enables you to do something, right? If an application requires a file to be saved, it asks the operating system to save it. And in order to save the file, the operating system needs to make use of the hardware driver, which performs the final save. The hardware driver talks to the hard drive, the solid state drive, the M.2, NVMe memory, whatever. It talks to it. It needs to know the code, the language to do that. Hardware. The hardware driver is a utility software that knows how to talk directly to the hard drive or a printer or scanner, a peripheral device like a USB stick, anything plug and play, all that sort of stuff. It talks to them. All right. Now, the operating system is responsible for managing the computer's resources, and somebody before told me what these were before. Storage devices, input-output devices, main memory, all the software that's currently running. That is what the operating system is responsible for. Now we need to start off here when we boot up. When you press the start button and we boot up, it has to run a boot cycle, right? It loads the main part of the operating system into RAM from BIOS. So BIOS holds the pointer to bring the operating system into RAM. Oh, they're all labelled 1, that's great. This part of the operating system is responsible for process management. It also covers low-level tasks that happen on threads in the background. That's what the kernel manages. Once the system has been loaded, the user interface part, the graphic user interface part is loaded. So the operating system manages inputs and output devices. So it manages input and output devices by communicating with and receiving data to a keyboard, a mouse, a monitor, etc. Or communicating with and sending data outwards as well. Look at this gaming mouse. That is the most stupid thing I've ever seen. It's got a fan. Incredible. Right. Now, the operating system manages spooling. Now, spooling is something that's normally talked about with printers, but that's storing data on a hard disk, in memory, in a queue, or in something called a buffer. And spooling is a process in which data is temporarily held to be used and executed by a device. And when you've spooled something, you've basically transferred memory. When you've transferred the memory, you can basically disconnect, unplug, and it will still carry on. It's like a printer when it carries on printing. All right. Data is sent to and stored in memory or other volatile storage until the program or computer requests for its execution. And to spool is technically an acronym for simultaneous peripheral operations online. Where am I going to post this? I'm going to give it to class teachers, and they'll send it out, or I'll email it to all students. I've not decided yet. I've not decided. Backing store. What's a backing store? That's all your storage devices. So ensuring that data is stored and can be retrieved correctly from any drive. Now that's maintaining filing systems. There are two main file systems that we use. So Windows tends to use a FAT file system, a file allocation table, or Apple uses NTFS most of the time, which is New Technology File Systems. And if you ever have to reformat a hard drive or a memory stick, you'll get asked what file system you wish to use. You choose one of those. NTFS uses both Windows and Mac. So there we go. Organizing files in a hierarchical directory structure. So here you can see Big Tom. Where is he? Tom. So Tom is the root. And then it spreads out. We have what we call a father file, son, and then you could go in third. You could grandfather, father, son if you wanted to. That's just a hierarchy of files. Also, the operating system manages RAM, random access memory. Has anyone got RGB on their RAM? If they have, I'm going to kick you off the live stream. Don't talk to me. Ensuring all programs and data, including itself, are stored correctly in memory locations so there's no corruption, and it ensures that all programs have enough memory to be allocated. So it moves things around the random access memory into different mailboxes. It can shift and reorganize and make better use of space. Okay, where is SNO? Oh, don't even go there. You're going to get me started. I'm going to ignore that people even use RGB. Utilizing virtual memory. What does virtual memory mean, and what is it? Does anybody know what virtual memory is? Okay, virtual memory. Virtual memory. Extra space on the hard drive created for lesser used data on RAM. Yes, so when RAM can't be used, we utilize secondary storage as RAM. The issue is the transfer speeds are incredibly slow, so it's not a great alternative. Most of the time, people don't use virtual memory because nowadays you are spoilt with the amount of RAM that you have. Spoilt. I remember my RAM, I had 128 megabytes of RAM. That was how much RAM I had when on my first computer. 128 megabytes. How we move. So the operating system can manage processes by ensuring that different processes can utilize the CPU and not interfere with each other or crash. It also ensures that all tasks appear to run simultaneously and make use of something called multitasking. That's when multiple windows are on screen at one time. Even though the process is only being used by one thing, it's swapping in and out, swapping in and out, swapping in and out, swap in, out, in, out. etc., etc. All right. You're not in the library tomorrow. Well, you are in the library. You're upstairs tomorrow, Israel. You're in 221. 221C is your room that you're in tomorrow because there's an exam in our room. Now, how can the operating system manage security? By allowing the creation and deletion of user accounts. That's one way. It also allows to log on and change passwords. A classic Windows XP. It was dead easy to find out your password on Windows XP. I got into many Windows XP accounts using that. All ethically, by the way. Just disclaimer, ethically. So other things the operating system does that you might not consider. It carries out compression. So data is reduced or made smaller. It's used to save disk space, even though that's not really an issue anymore. And it performs things like defragmentation, which is fragmented files getting split up and getting put all back together. But SSD does not have fragmentation or defragmentation. It uses a trim command instead. Yep, compression. We have lossy compression and lossless compression. All right. So, okay, utility software, antivirus, compression, debuggers, screensavers, system monitors, system resources, processes, memory, peripherals, and backing store. Now, what about an interface? There are two, and I've already mentioned them already. So the word interface, what does that mean? It means devices come in many different forms. We've got mobile phones, we've got very small screens, we've got very large screens, full TVs, we've got projectors, etc. And the operating system has the job of allowing us to interface with them, especially touchscreens and things like that. Now it does that by using something called a device driver. I've already explained what this is. But the interface deals with a device driver, and that converts the commands to the operating system. Sometimes device drivers are installed as standard, and there are generic drivers. And sometimes you have to install specific drivers. So gone are the days when you would have your device drivers on a disk. Imagine having to put a peripheral device into your computer and installing it with a disk. Most laptops don't even come with CDs anymore. Crazy that, isn't it? How we've changed. Okay. So the driver converts commands into binary control signals using the diagram on the right hand side there. You deal with your program, your operating system deals with the outputs of your program, communicates with the device driver on your behalf, and then executes the commands. All without you even knowing. That's crazy. The operating system does so much. I hope you're grateful, people. I hope you're grateful. So normally, each hardware device has two codes. So this is a printer, for example, has two codes. There's a vendor ID and a product ID. When a device is connected, the operating system queries the device for the two codes. So it asks for the two codes, and it checks if those codes are already in our default drivers. And if they are, we don't need to install anything. And that's what we call plug and play. Crazy, right? And you, with your fancy graphics cards, installing your drivers for all kinds of stuff, you can go on their website. Most of the time now, people get drivers from websites of manufacturers, or they download automatically using the internet. Yes, good times, good times. So you need device drivers for every device, pretty much. So sometimes the operating system will install generic drivers to make sure it can use everything that that hardware device has to offer. Okay. I don't think we need that one. Yeah, we don't need buffers and interrupts for this. So there's an example of a command line interface on the left hand side there. Command line interface, what are the benefits of those? The benefits are, usually they're very straightforward and to the point. The issue with that is they require some level of technical ability to use. On the right hand side, we've got a graphic user interface. Graphic user interface are for people like you. Yes, people like you. Novices. Novices. Okay. Now, HCI is a very complex and highly paid, highly skilled field, actually. It's the discipline concerned with designing, evaluating, and implementing interactive computer systems. Now, Apple are famed for their graphic user interfaces and their style. And then Windows have made good progress in this area with Windows 11, which people seem to like. But sometimes there are bad examples. Bad examples. Now, this isn't computers. This is like just general human-computer interaction, HCI. Some of them are not good. Okay? So with graphic user interfaces, you've got things like they're intuitive. There's no need to memorize complex commands. You can have help facilities. They can promote multitasking. Sometimes there's high requirements in terms of hardware, so you have to obviously have graphics cards, sound cards, etc. And experienced users can be slowed down by an excessively helpful interface with lots on it. Okay, sometimes it's quite daunting. And there's your command line. So Israel was talking about Linux there. The stuff you did for Cyber Centurion, that is a command line interface. And you know how difficult that was if you didn't understand the commands. You had lots of trial and error. There's minimum hardware requirements. That's why it's very fast. And the commands can be entered by an experienced user very quickly and get straight to what they need. Okay. All right. MS-DOS. Yes, that's where it came from. MS-DOS. So different operating systems. We've got single user operating systems. That's what you use at home. That's like your user and your multiple accounts that you can have. So one admin and multiple account users on your personal computer. And you have multi-user operating systems, which is more like what the college does. So the college has many accounts under one server, and you all log in and access that. Now, the good thing about multi-user operating systems is we can issue out different time slices of the server, so we can give people more processing power if they need it, more storage if they need it, etc. The best thing to do, Yusuf, with past papers is to go on our Google site where all the papers are for our exam board. Don't do other exam boards because they have different specifications. We also have a multitasking operating system, and that's the process of swapping applications in and out of the CPU, giving the illusion that they're running in parallel. The issue with that is, if, for example, you've opened too many windows and it crashes, then you've got a serious issue because everything collapses and it says not responding and it all gets shut down. All right? So the operating system's job is to swap things in and out as fast as possible. So multi-programming operating systems are where the computer system stores more than one job in the computer's main memory. That's random access memory or cache at the same time. And these jobs appear to get processed by the computer's CPU simultaneously, but they don't. They're just loaded, ready to go in RAM, so they can be executed extremely quickly. And that, again, gives you the illusion that things are going on when they're not. And it allows us to make better use of the CPU by preventing it from being idle. If your processor is idle, it is a big waste of time for the computer. All right. Can anyone state the three modes of operation? Last thing on operating systems, this. 3 modes of operation. Any ideas? Three modes. We've got batch. Batch is one of them. Yep. Real-time transaction. Yep, and real-time control. Very good. So there's actually two. Real-time and batch. So, real-time control and real-time transaction. Transaction involves money. Control is immediate action upon input. So we've already talked about a batch process with our master and transaction files. So I won't spend much time on this one, okay? But data is used by batch process. It gets stored in a temporary file for a short amount of time. That's the transaction file. And then it gets merged with the master file at regular time intervals. And I'll leave that on the screen for a second because we've already talked about this. And there is a perfectly drawn, thank you very much, I did it, perfectly drawn example of your gas bills getting updated. I put a little summary of the master file, a little summary of the transaction file there as well. So don't forget, with batch processing, it performs many similar tasks or jobs serially, that means one after another, without user intervention. Apart from the user starting it off. Each job will only differ in the data it uses, and computers are very good at number crunching. So this is easy for a computer. Batch processing has the following properties. So it's got a large number of similar tasks or jobs, and it can be run without user interaction, and it's able to run during or outside of office hours, which means there's no load on the system, so everyone goes home and we can still use our system. So with batch processing, we used to use something called mainframe computers. They were very heavy duty computers that just number crunched. And it requires a large amount of CPU time, long time to complete. More jobs equal more time, obviously. Once the batch process has started, it will not require any user involvement again. So we just leave it to go and carry on with its life. Any errors go into a log file, like Isra told me before, and only if there was a serious error would the batch process actually stop and require user input. Somebody comes in the morning, checks the error file, and carries on doing that by hand. Right. And then it produces something like that. It can produce automated PDFs, for example, and can be used to produce payroll, bills, gets data, puts it in, produces large volumes of outputs. And that's it for batch processing. Now, a real-time operating system, there are two types, doesn't it? There's two types. So real-time operating systems must respond in a short amount of time. And you would only use one of these if you had the money to do it, because they are quite expensive. And you wouldn't expect to run a real-time operating system on a desktop PC because the unpredictability of software applications and the software they might install, the potential for power loss, etc. It's too high risk. So no matter how good your operating system is, a web page could not load in real time because of the broadband connection bottleneck. It's just not fast enough. So we don't use that. Real-time operating systems only run, they're very specific, and they only run on certain systems. And usually those systems are what we call mission critical systems. And that's where there's a risk to human life. So can anyone give me an example of a real-time control system? A real-world example. Yeah, power saving mode. That's where everything goes slower. Any examples of a real-time control system? Okay, so we've got power station, armed forces, so the military, yes. So military systems, but you need to be a little bit more specific if that was going in your exam. Okay, one that I'd go for is something like this. Yeah, Tougher Joel, I'd go aircraft systems. Now, why? Because when I think about an aircraft flying and using its systems and its readings onto the cockpit dashboard, or if it's in autopilot, it takes in millions of inputs every second. Every single system updating everything, and it's a very, very complex web of inputs, processes, and outputs. So, aircraft systems use inputs to produce outputs. And somebody also said nuclear, so power stations and things like that. That is Chernobyl. That is the disaster that happened. If they used a real-time control system, the outcome may have been different. But real-time control systems, as long as you're talking about a risk-to-life system, you'll be fine. So we've got some examples of systems that require real-time operating systems, like nuclear power stations and aircraft systems. And if the decision or action was delayed because of software running slowly, it might explode, which could end in a disaster. So you've got to be careful. Now, real-time control processing, they could be used to monitor and control temperatures, like in your nuclear power station or your greenhouse. It gets continuously monitored every single second, and the inputs are processed immediately, and the outputs are adjusted immediately. So outputs could be through an actuator, a motor, a light, anything really. We can adjust anything. Accidents can be avoided. So, if you're monitoring your nuclear power station, you can monitor temperatures faster than a human can. The whole system can be automated with very few operatives monitoring, so you don't really need people. Also, you can, if you're in a hospital and somebody's on life support, a nurse might not need to watch over that person. It could alert nurses to something happening immediately, so you can send signals somewhere else and alert people. And we can continue taking inputs, and we can basically stack jobs in a queue until they're ready to be processed, which makes better use of the processor, which is good. So if that's real-time control, what is real-time transaction then? Real-time transaction. So transactions to do with money. So this happened to me. I bought Peter Kay tickets, and I got stuck in a queue. I was 64,000 in the queue, somewhere like that. And I was waiting for these 64,000 people to check out. Now, those 64,000 people had access to the tickets, and I was locked out. So I can't get access to the tickets until somebody relinquishes control or buys the tickets. So some transaction-based systems are considered to be real-time. If one store books the last C of a cut price holiday, it should no longer allow the other user to book. So we're preventing double booking. Okay? So stopping multiple bookings from occurring. And that's why it needs to be real time. This is the same with banks as well. Let's say I have £100 in my bank account. Teaching pays well. £100 in my bank account, and someone charges me £100 for a bill, and then I go and buy a sandwich. The bill should be paid, and the sandwich should not let me buy it. It needs to be in real time. It needs to update in real time and prevent me from purchasing that sandwich. So real-time transaction, that's the one we see in the exam normally, selling theatre tickets. So when a record is accessed, other users are locked out and the record is updated immediately, and it avoids double booking. Simple as that. And that's the end of operating systems. The end of operating systems. Now it's time for a vote, people. Time for a vote. Right. There's 15 minutes left. We have a choice. I've got 3 things on my board in front of me here. We've got networking. We've got truncation and rounding. And we've got systems analysis. Which one do we want to do? Networking, truncation and rounding, systems analysis. Most votes gets it. Get in the chat, get typing. Oh, systems analysis is taking it. Systems analysis. Okay. 1, 2, 3, 4. Right, okay. Right. Systems analysis is there, people. If we look up there, though, we've got methodologies, feasibility, investigation, and analysis. Do both. I'm not doing both. Well, therapist. I'm doing one. So there's your life cycle, right? That's what you're going to do. You've got feasibility, investigation, analysis, design, changeover, program testing, maintenance, backup and recovery, and documentation. Let's get going. So when we develop a new system, we have to start somewhere, and normally that involves a discussion. So that's called the problem definition. So we sit down with someone and we talk about what they want in their system. Then what we need to do is produce or create a feasibility study, right? The feasibility study is working out whether it can be done. And we use the PETAL model for this. We check if it's politically, economically, time and technical and legal in its feasibility. So is it legal to do? Do we have enough time to do it? Are we going to make enough money from it? Stuff like that. Okay? So, skip through that. Investigation and analysis, right? You need to carry out a full investigation. So this is only if we've passed the feasibility study, right? If it is feasible, we go ahead. Then we look at investigation and analysis. So we have to understand what's currently in place and work out what areas of inputs, outputs, and processes do we need to develop. And we can do that using a number of different methods. We have an observation, a questionnaire, document collection, an interview. They're the 4 methods of gathering and fact finding. An observation is good because you are watching the system being used, but you need to choose your times when to watch. Now the observation, when you watch someone, sometimes they behave in a different way. So sometimes you might get a bit of bias. So you need to bear that in mind. Questionnaires are good because we can send them out, especially electronically, to large amounts of people. Problem is, people return stupid answers or they just don't return it at all. Document collection, it's good because documents don't lie unless they're redacted. So the government and the military, they tend to redact secret or private confidential information. Interviews are good, but they take a long time. The good thing about interviews is that you can ask follow-up questions. But again, like I said, they do take a long time, so we don't do that many of them. And you need to pick the person that you're going to interview. If you're going to interview Bob, who's working on the fryer at McDonald's, he ain't going to have as much clue as the store manager, right? So you pick your people. Then we have requirements, interface requirements. So after we've done the analysis and the investigation, what are we going to start to build? Well, this is what the interface should have in it. What functional requirements? How should it function? What are those requirements? What is its performance requirement? So it should load in a certain number of time. We should allow 3 clicks to get to this page. That's it. And then we build a loose requirement specification at this point. Okay, now these are all the slides that I'll send out later on, which have advantages and disadvantages of each collection method. There's our requirements for our interface, functional, and performance. Requirement specification. Now you're going to build one of those in your coursework next year as well. And then once you've worked out it's feasible, once you've investigated it, the next thing to do is design the thing. Now to design the thing, I will, Rohan, yes. You can design the thing and build everything. Now you don't build and prototype it yet. What you're going to do is you're going to build a replica, you're going to do diagrams, inputs, outputs, data structure designs, you're going to do flow charts, maybe some pseudocode, for example, so that you can hand that to someone else and they can build it. So these are the kind of diagrams that we can produce. So you got flow charts, top right hand corner, Jackson structure programming diagrams, bottom right, you've seen those before, entity relationship diagrams, a data flow diagram's in the middle, and you've got something called a UML diagram. These are all standard diagrams that we use in computer science. You won't be doing any UML diagrams, but everything else on there you will do. You'll do DFDs and JSP diagrams in the next year, only if you make it. So in the design bit, inputs, outputs. Let me just go back a second, talk about these. So the interface design shows the data that will be entered to the system. You list as many inputs as you possibly can, and you list as many outputs as you can of what it should look like. You don't always get this perfect, and sometimes you have to go back. In the design, you show how the system will work, you explain the data that needs to be stored and by what data structure, and the information for the data structure usually comes from something called a data dictionary. Data dictionaries include information such as the name of the data type itself, the data size, and the description of the data. And also, you do what validation is needed, and that gets put in a table. And that's what the data dictionary is, it's a table. Okay? Now, in here, we've got different types of abstraction when it comes to this, because you are the systems analyst and you are producing an abstracted view of what you want somebody to create, right? Now, what you've got is these two types of abstraction. You've got control abstraction and data abstraction. So control abstraction hides actions and programming control, like machine code from the developer or the compilation process. And you've got data abstraction, which hides how bits are organized, and that hides complexity. So why are we doing this? Why are we trying to hide stuff at this point? Because we're going to give different parts of this project to different people. And we don't want to make it so confusing that they can't do it. And that's where decomposition comes in. Now, decomposition is the breaking down of something. And in programming or system design, programs can be broken up, and we give each part of the program to different people on our team. So when a piece is sufficiently decomposed and manageable, we issue that out to the development team with a deadline date. They must complete it by the deadline. All right? And you've got some exam questions in here. I don't know why that's there, actually. Why is that there? That's like a random number question. Ignore that. Now, the next thing, this next bit, changeover, there's usually lots of questions asked about this because it's quite an accessible topic. There are 4 methods of changeover that we need to know. Can anyone tell me any of the methods of changeover that we use? And changeover is bringing a new system in replacement of the old system. So we're changing over from the old to the new. There's 4 methods of changeover. Can anyone tell me what they are? Direct, parallel, pilot, and phased. Okay? They are the 4 methods of changeover. And changeover is the command word that gets used in the exam. You then need to be able to talk about the 4 that you can see on your screen. And I've put some little arrows so you can see what's going on there. Direct changeover. Let me just see if... Yeah, changeover methods, right. So direct changeover, it stops using older systems immediately in replace of the start system. That's why it's called the Big Bang, because it's very risky, right? It's a straight swap over. It is the simplest option because you're getting rid of old for the new, and it's a straight swap over, but it can be very dangerous. The highest risk of all the changeover methods. And it's most useful where there is no old system or the old system is broke or unworkable, right? Then we've got direct problems such as bugs, lack of training. Problems can result in loss of productivity. If the new system fails completely, we have to shut down the business and stop production or stop working. And even though the new system would have been tested, there's no guarantee it works as expected using live data. So they're the problems with our direct changeover. With phased changeover, phased is we are bringing in a new system a little bit at a time and phasing out the old system a little bit of the time. Okay? So big projects are normally split into separate modules. It works best with certain methodologies such as rapid application development. So when it talks about methodologies, we're talking about things like agile and waterfall. They are methodologies, they're methods of implementing this whole cycle. Initially, only part of the new system is implemented, one module. See if it works, test it, make sure it's working, and then introduce the next bit. That's what phased is all about. Now, this does mean that the old and new systems must be able to work together, and that's not always possible. And if they are completely incompatible with one another, then a phased approach can't work. The phased approach works best when small companies are upgrading, or it's an existing system implementing a brand new system. Right? So you're upgrading an existing system or you're implementing a brand new one. It's not suitable for companies with loads of different premises because it's difficult to manage across multiple sites, and that's where pilot comes in. So pilot is when large companies or organizations tend to have more than one site, like a supermarket, for example. You have each site does things very similar, like again, where Amazon warehouse, and it's perfect environment for a pilot changeover when that happens, and the system is implemented on one site only. It's tested. If it works on that site, then we roll it out across other sites. So, if the system is faulty or there are problems, then only one site is affected. Therefore, it's not a major problem because we fix it on one site. It's less impact to our business. And it's an ideal model for any business that has many similar branches, and it's not suitable for companies spread across many sites with each one doing something different. So as long as everyone's doing the same thing across all the sites, then we are good to use pilot changeover. I think it's the last one, parallel. This is where system failure cannot be risked. So this is the best tolerance, but it is the worst for usage of the system. And by that, I mean that because you're running two systems at the same time, it causes duplication of all tasks. And that can be a problem, especially for memory and things like that, especially if you're doing backups and stuff. All right. If the new system fails, you can fall back on your old system, and staff will have to do double the amount of work. So for every order, they need to enter it into two systems rather than one. All right. So you've got both systems running at the same time with parallel. Now, staff can get pretty miffed off if it's used for too long. So it's important that you don't keep this parallel system running that long. So parallel is the safest type, but it also requires the most work, and it's best reserved for critical systems like those used by banks, for example, where loss of even one transaction can be a right nightmare. What a nightmare. Okay. So there you go. You can pause the video there if you want to. That are all the changeover methods all in one. Now we have to talk about testing. So we have defined the problem, checked the feasibility. We have analysed and investigated. We've designed. We've then built the system now. And after we built the system, we need a number of different types of testing. We have white box and unit testing, black box testing, alpha and beta testing, which you've probably heard of because games do that. End user testing also. Now, what data do we use in these tests? We use something called logical pathways, which means you're going to direct in multiple, you know every path. We have normal data, we have extreme data, and we have erroneous data. So normal data is valid. Extreme data can be valid or invalid, but it's to the extremes of the data type, like a number, a really high number, or a really low number, or a negative number. Erroneous data is data of a different data type. So if we're expecting a string, I'm going to put in a number. See what happens. Okay. White box Structure of the code is tested. We require all the knowledge of the code and how it's developed. Each path must be tested. Black box is different. We give someone a script. They carry that out. They don't care about how it works. They just put stuff in and expect something out. Okay. Now, unit tests, they run the code to be tested with various sets of inputs. Now, I personally like unit tests because they're automated and they get set up at the start of the project, and we can use them as many times as we like to test our data. There's example data down there, what I described before. If you want to pause that, you can have a look at the data that we use. And then we've got alpha and beta testing. Alpha testing is conducted by the developers or testers, typically module by module, subroutine by subroutine. Beta testing is conducted by prospective end users who use the system as they would use the end product. That notifies the developers of any bugs and they identify them and fix them. All right. Acceptance testing. So acceptance is you accepting the specification, so that's normally with the stakeholder at the end. That is very risky, and I've seen people get very angry when they've not accepted it. And end user testing is when you get people in that are actually going to use it, and when they use that, they will give you feedback, and they're real end users. Now, there are 3 types of maintenance that we need to cover now. Yeah, no, this is enough detail, Maruf. This is enough detail. Now, we've got 3 types of maintenance. We've got adaptive, perfective, and corrective. So these are quite nice and simple and straightforward. I've seen a few 6 markers on these. I've seen a few 8 markers on these. So perfective maintenance aims to make a functioning system even better. It tries to match the specification perfectly. That's the point of it. So it might be tweaking an interface, speeding up network connections, that sort of stuff. We have adaptive maintenance. So adaptive means that we might need to change something like GDPR or VAT rates have changed. Not likely in this environment now, but we might need to make changes to the program. So adaptive maintenance. Then we've got corrective maintenance as well. So corrective maintenance exists to remove bugs that were not addressed during the testing. And it might not even be your system. You might be performing corrective maintenance on a system that's not even yours. It's not even yours. Then, after you've maintained and you've got your maintenance contracts, we've got backup and recovery. So backups, remember, are copying files from one storage location to another. This is not archiving, okay? Archiving is moving the files. This is copying the files. So every organization has something called a backup policy, and you've got to remember these things. And these are on the slides before. Where will the backup be stored? What will it be stored on? How often will it be backed up? How long do we keep the data? Okay. Now, why do we do a backup? We do a backup for preventing loss or damage. An incremental backup can be done. We have a heavy load on the system, so it can be done overnight, and it takes a long time to back up the full system. So it costs a lot of money to purchase storage, so we need to buy more, okay? And finally, we've got documentation. So there's 3 types of documentation that you need to know about, and that's internal, technical, and user documentation. So internal documentation is the code itself. You send that to someone. That's inside the code, is sensible names, good comments, and good layout of code that's provided. We've got our technical documentation. A technical documentation is written by the developer, so it's very technical. The jargon that they use is really specific, so not everyone can understand that, and we never give that to the end user. It has all the diagrams created during the design, and it has all the testing involved in there as well. And user documentation, that is your end user. No technical information, just information on how to install, uninstall, and resolve problems. So frequently asked questions in there. All right, so they are the different types of documentation that we use. Okay. Now you've got evaluation in there, so we need to evaluate our system. So we have requirements, make sure we've met them all, the performance of our system, how robust it is through testing, and also the cost involved in that as well. And how usable is it? Okay, how usable is it? That's my doorbell. Okay, so we're going to stop there, people. That is the end of the session. If you've got any things in there, please just let us know. Put it in the chat. I do have to go and open my door. I will respond to questions, so keep putting them in the chat. Okay, let's check in what questions we've got there. Classes contain, right, so objects. Add your questions on the Google chat. Send me the answers. I'll send you the answers, Rohan. I'll write that down. Stop complaining. Yeah, I wish I had a new graphics tablet. I might look into that. Okay, you're just talking about random garbage. Yes. Okay. Yeah. All right. So all of this, all of these documents here. So I'll send this out. I'll send it out as a PDF because there's no way I can email this to you because it's just too large. But so it'll just be a linked PDF. It'll still work the same. For object-oriented programming, I've got that in there under principles of programming. I can show you that. It's object-oriented that you want. Now, object-oriented will be in paper 2, remember. So procedural, visual, all of our different event-driven, all in games that we use for our event-driven. Event listeners, more event-driven. 2 markup languages, HTML and XML. Markup languages, yes. Non-procedural languages, so MPL languages. Yeah. Okay. Well, it's not got object-oriented in it. I will put that in, though. I'm just going to do that. No. OOP. I've never seen it in paper 1. I've only seen it in paper 2. Are there any more in the programming? In the programming exam, which word processor? You have to use the Word, Microsoft Word. Okay. Right, people, a couple of things for the exam on Tuesday. Make sure that you turn up in plenty of time. Have a good night's rest before that. Eat well. Drink plenty of water. Right, you've got to keep yourself fit and healthy and fresh for the exam. Practice papers. My class got a set of they got a practice paper today. They'll get one tomorrow as well. For those classes, if you're supposed to be in room 242, period 1, period 2, you will be in room 221C. In room 42 for paper 2. The rooms might be changing. You'll see. The aim is we're going to try and get all the people for the computer science exam in rooms on normal computers. That would be the plan. This is for A-level. All right. Thank you very much for coming, people. You know what my email is if you need to ask any more questions. But thank you very much for taking this time to revise with me. And I'll see you all tomorrow. Thanks very much.